SQL, Python, Bash, Cloud, and the JVM languages. Hey everyone, welcome to another recall by Dataiku. Today we'll be going over the necessary skills in order to be a successful data engineer. Now, if you watched Joe Matek's wonderful video on data scientist versus data analyst versus data engineer, then you'll know that data engineers are primarily focused on the bottom section of that pyramid and are mostly focused on getting data from one location to another location in a clean and efficient manner. Now, while this may seem like a very simple problem, as the number of systems you have to connect to grows and the amount of data you work with exponentially grows, moving data from one section of a system to another becomes a very complicated distributed systems problem. Distributed systems just referring to how you can use many different computers to process a single data set or accomplish a single task instead of having one very large, powerful computer. Like I mentioned at the beginning of the video, the most important skills you'll need to focus on in order to become a data engineer, at least the technical skills, are SQL, Python, Bash, the cloud, and JVM languages. And this is, in my opinion, at least in the order of importance, assuming you don't know anything at the moment. So let's go through each of these skills one by one. And then at the end, I'll go through a real-life example of how these skills were used in order to actually save tens of thousands of lives relatively recently. First, SQL or SQL. SQL stands for Structured Querying Language and is the primary way that we as data engineers manipulate data. And the reason it's so popular is because it's relatively easy to learn, and therefore it's easy to expect many different people to know how the language works. So anyone from a data analyst to a data scientist, they're going to know how to use SQL. While it's simple, don't get confused, SQL is extremely powerful. You can use it to create entire databases, insert data into those databases, and then query and transform the data in those databases, all with one easy-to-learn language. Now, there are data engineers who make entire careers off of basically just knowing SQL, but it is important to note, based on this tweet from Zach Wilson and my personal experience too, data engineers who also know how to program generally get paid a lot more. Next is Python. Now, if I'd written this list a couple of years ago, Python may not be this high up on the list. But in the last couple of years, Python, because of its popularity in the data world and just its general ease of learning, has become a first-class citizen in many data engineering applications and is definitely a language that engineers should know how to use. Python is generally used when you have to perform more complicated transformations on data or perform transformations on extremely large data. You'll use distributed frameworks like Apache Spark or Hadoop in order to actually pipe in this data and transform it. Apache Spark, while written in Scala, which is a JVM-based language, now has a version called PySpark, which is a first-class citizen in the framework. You may then decide to orchestrate your entire pipeline workflow using something called Apache Airflow, which uses these things called DAGs, which are written in Python. The point being that a lot of the base frameworks that are used in data engineering are either based on Python or have input versions that allow for Python usage. Additionally, data engineers oftentimes are making APIs or application programming interfaces which allow data scientists and data analysts to connect to their databases, and these can be written in Python as well. Skill number 3, Bash. Bash in this case just refers to the ability to use the terminal or the command line. And this is a skill that you'll most likely pick up if you know how to program, if you learned Python already. Now, Bash, or shell scripting is probably what it's technically called, is important to learn because oftentimes you'll be working with computers in the cloud where you may not be able to access a graphical user interface, and you'll interface with these computers usually using the terminal. And oftentimes a lot of tasks can be accomplished a lot faster using the terminal. Additionally, you can use Bash scripting or shell scripting to perform some very basic data transformations on your data. So if you need to get something done really quickly, this is oftentimes the fastest way to do it. Speaking of cloud, skill number 4, one of the most underrated skills, in my opinion, for data engineers to know is the ability to work with the cloud. As the scale of data that regular enterprises are interacting with goes up exponentially, the cloud offers a solution to scaling your compute or the number of CPUs you have available to you infinitely as well. Many organizations are still working on their transition to cloud. And as you transition into the cloud, you're most likely, at least in the United States, to encounter AWS, Azure, or GCP, those being Amazon, Microsoft, and Google's solutions respectively for cloud solutions. The core technologies behind a lot of these clouds are very similar. They all have basic storage, they all have databases, although the databases are starting to become a place where they're differentiating each other. I'm looking at you, Google BigQuery. But the cool thing is basically all of these providers, Amazon, Microsoft, and Google, offer a solution where you can sign up for a free account and just mess around with their infrastructure for free. If you want to practice your skills in the cloud, I highly recommend doing this because doing something on your laptop is not the same thing as doing it on the cloud. Like, there's a lot of similarities, but there's also a lot of stuff you have to consider when you do stuff on the cloud. One of the major ones being that if you write inefficient code on your laptop, the worst thing that can happen is it just takes too much time. If you write inefficient code in the cloud, or you don't manage your tokens well, and they get leaked to the public, you can end up with a multi-$1,000 bill. Finally, skill number 5, we have JVM languages or Java Virtual Machine languages. Now, it is often said that Python is always the second best language for any task you want to accomplish. And what people mean when they say this is that usually tasks are meant to be accomplished in a specific programming language, either because a framework was written in that language or that language just has features that are useful for said task. But Python is so easy to learn and is a full-featured programming language, so a lot of people will end up using Python for things simply because it's easier to find engineers who can write in it and it gets to the solution a lot faster. Now, a lot of these big data frameworks, stuff like Hadoop and Spark, are written in JVM languages. I think Hadoop is Java and Spark is in Scala. If you want to start messing around with the internals of how these frameworks work in order to maybe speed up your processing or something, then you probably will have to learn a JVM language. Now, this is also why I put it as the last priority, because it is probably the most difficult skill on this list to learn and will be used in the most niche manner. I don't want to say it's used the least, because there are some people whose entire jobs are to work in these languages, but it'll be used in the most niche manner in most cases. And those are the 5 technical skills I believe are important for a data engineer to have. Now let's go through a real-life example of how these skills were used to actually save many, many lives. Now, before we get to our real-life example of how all these skills are used in the real world, you might be thinking to yourself, it seems like a lot of these skills are really coding heavy. What if I am a data analyst or a data scientist who's more mathematically focused or doesn't code too much? How do I interact with data engineers? Well, typically, a data engineer needs to get the data in a format that is easily readable by business leaders, data analysts, and data scientists. Oftentimes, this means that the engineer will be given a task and then will work on it for a while, show the end users, and then fix anything that they need to. Dataiku offers a great alternative to this by having a coding and no coding platform, as in a platform that accepts both types of users, and a collaborative, easy to use graphical user interface with APIs that allow you to use your favorite tool for data manipulation. What this means is that people of different skill levels and different skill sets can all work together simultaneously so that engineers aren't working in their own little silo, which can potentially lead to a longer development cycle as the engineers and the data scientists and the data analysts have to go back and forth with requirements gathering and actual execution. Check out the link in the description below if you want to learn more about the Dataiku Total AI platform. Now, as you may have noticed, I'm in a hotel room right now, and that hotel room is located in Seoul, South Korea. That's the Metropolitan Building over there. Or, sorry, no, that's Hana Bank. And we have the Seoul Finance Center right there. Now, South Korea had a very interesting solution to the pandemic that happened to us recently. They were able to prevent mass infections while still not having the citywide lockdowns, which were so common in many parts of the world. Now, there were many reasons that they were able to do this, but one of the main reasons was that they were able to pinpoint where the public could go buy masks when the mask shortage was going on. And the process of setting up the IT infrastructure and the data infrastructure to communicate inventory stocks to the public, along with the location in an easy to digest manner, was most likely handled by data engineers. So let's walk through the problem over here. You want to make sure that people are able to know where masks are located, like which retailers have masks, because there is a mask shortage going on right now. How do you do it? Well, first and foremost, you'll have to aggregate all of your data. You'll have to gather your data from your different data sources and put it all together in one database. Typically, you would connect to many different external databases using a cloud service. One way that you can handle this, and I'm not sure if this is exactly how they handle this, but one way you can handle this is to have the retailers publish their results, publish their inventory stats into a bucket, which is basically a storage solution in the cloud. It's just, a Google Drive in the cloud, basically. And then your database will pull data from that. So this is where knowledge of cloud technologies is very useful. You have to know which cloud services to use in order to, pull that data and to set up that bucket and all. Next, you'll have to go through all of that data and clean it. The different retailers will probably input the data in different formats. So you'll need to standardize the formats between the retailers, combine all the data, make sure there are no repeats, make sure the data is clean, remove unnecessary products. And depending on how the retailers actually queried masks, you may be even getting masks that are not very effective. So maybe you want to devise a ranking system for the different masks. I believe a recent study said that cloth masks are least effective, then there are surgical masks, and then there are those N95 masks that are the most effective. So all of this data transfer transformation and all of this data cleaning and standardization, that would be handled in SQL most likely. Okay, so now you have all of your data inside a database. You've pulled it in using cloud services. The retailers have put it inside a cloud bucket, and then you've pulled it from there. And then you have used SQL in order to actually clean the data and standardize it and put it in a nice clean table that can now be used. What do you do next? Well, typically you'll want to do something like data enrichment. You want to add more data to the data that you already have. One really big one is that just knowing the name of a retailer is not necessarily useful, because you want to make sure the public actually adopts your tool. So you want to give them as much information as possible. So things like when are stores open and close, where they're located, stuff like that can be very, very helpful. And this is where you want to integrate with a mapping API. In South Korea, they'd use Kakao Maps or Naver Maps. And so that integration over there is another thing a data engineer would do. They would use something like Python in order to query the Naver API or the Kakao API, basically the mapping API, and enrich the data they already have by adding locations and store hours and stuff like that to their data set. And this is also where it's very important to be good at your job and understand that you don't want to just ping the API every single time you need a result, because you get charged for that. So you want to probably store your results somewhere and only update them whenever it changes on the API side. And that entire integration can be built in Python. Okay, so now you have a database that has all of your data. It has a bunch of extra data inside it. What do you do next? Well, the public has no idea how to access databases, so you need to find some way to give them the data in the most effective way possible. Typically, you leave this up to third-party developers, but how do the third-party developers access your database? It's never a good idea to just allow someone to get directly into your database. You need to gate access to it. That way people can't abuse the system and you can control access. This is where an API would come into effect, and you could again use Python or Java in order to create an API that allows people to connect to your database while still allowing you control over who gets access to it. And there you have it. That is exactly how data engineering can be used to solve a problem such as letting people know where masks are available during a mask shortage. I hope this video has been informative in telling you guys the technical skills that are necessary in order to become a data engineer, and how important the work that data engineers can be for society. When stuff like this happens, big tech companies such as Google, Apple, or in the case of South Korea, Naver and Kakao, actually do get their engineers to help build out these solutions. Now, if you want to get more information on the big world of data and all the crazy stuff that we've been doing inside it, subscribe to Recall by Dataiku. Thanks, and have a great day.